Hi everyone. I have today here with me three of my colleagues, Mihai, who is an architect, Maria and Johan, who are data engineers. And today we are talking about IoT, IoT especially in logistics, but not only. So welcome everyone.
Welcome.
Good to be here.
So talking about IoT, what was the project that you were involved in that was kind of also challenging for you, and what was also its main objective in this matter?
Okay, I'll take it. So, without naming the client, it's a big company that has a lot of vehicles that are sending data to their system about their position, acceleration, braking, every type of events. They have more than 1 million vehicles that are doing this. And they came to us with an interesting request. Given that they are such a big company, they said, could you help us to re-architect our streaming platform and to help us on the data trading on the batch platform? And our first question was, how come you're such a big company and you're just doing that? And we were thinking, okay, maybe they're faking it. They clearly have something in place. And then we went there and they had some architecture in place, but it wasn't scalable. It wasn't configurable enough. And then we came into the picture, and it was really nice to work for such a big company and to also have a greenfield project, so to say, where we had all the freedom to reconfigure everything. Now, in terms of what we did, we just worked on the cloud part, on data processing part. They had special teams for devices. They had special teams that were working the contracts so that the devices could send the data to the cloud, so internet connection and so on. Then they had another team for the on-premise system that was the old system that was helping all of the other clients. And then we were helping them to expand to the cloud and migrate to the cloud business. So our main challenge was figuring out a system that scales well and is configurable enough for delivering data in 3 minutes from vehicle to the end client, given that the end clients are also businesses that all have different requirements. This was the main challenge of this project, and what it was interesting is that they also chose technologies that were advertising themselves as being good for this. And now I'm talking about Spark. And they were using Spark, and on top of it, it was a technology called Databricks, which is offering you in Azure or AWS or Google Cloud Spark serverless, without managing the servers or anything. You could just run Spark. And while they were advertising as being a fast and good enough solution, we realized slowly that it wasn't good enough. And then we slowly realized that Event Hub, which is a serverless tool from Azure, which has also Kafka API, we realized that also that's not scalable enough for what we need. And we ended up on the 4th or 5th solution on having something scalable and performant enough and configurable enough. And weird enough, the solution was, in the end, a distributed file storage that's fast enough, put on SSDs. It's called a premium blob storage, again a serverless solution from Azure. And that, in combination with Spark and Azure Event Hubs and Azure Functions, in the end deliver the solution. So it was really interesting as we moved through multiple suggested solutions to the public solutions that you would normally get when you ask about this type of problem, and ended up with something that's not that usual at the first search, but as you look through the companies, you see that a lot of companies are actually doing it when you reach scale.
Okay, so this is like more maybe an architectural overview or insight. What do you think from a data engineering point, what were your also tasks, but also challenges in this matter, as looking on the process on those projects especially?
So as Mihai said, mainly he described the solution that we had for streaming the data, but there was another part of this project which was related to the batch delivery of the data, and mainly I worked on that part. And in there, basically what we did is to reduce the time that it took to develop a solution in order to deliver data to the customers. And from, let's say, 2 weeks, we reduced it to 1 day. Basically, our solution was better from what was there previously. And we managed to actually deliver ad hoc deliveries, ad hoc requests that we had from their customers.
Okay.
And this was one of the, let's say, key features that we came with.
Okay. Maria, anything to add? Do you agree? So to say.
What I was thinking that was a challenge before, and we succeeded to do, was basically to automate the CI/CD process, because previously they were manually updating their stage and production environment, but they were not properly automated and not the correct way to do that. And what is now happening is that you develop on the development environment, then it automatically go to the stage environment where it's fully tested, and if everything works fine there, it goes to production with a manual release.
Okay, I understand. And if we took it on the process base, so we make it also to our audience a bit simplified, so to say, how is usually, or how in this case, how was the process before or afterwards in terms of functional things that were working behind that you had to improve to technology through this IoT environment, basically?
So initially, as it's a big corporation, first of all, there were a lot of components involved in the pipeline. And as for the streaming one, we tried to remove as many of the components as possible and reach as close to the source as possible, because every component was adding possible downtime, possible problems, and we wanted to have it as centralized as possible and as secure as possible, as also anonymizing data and making sure that you don't have security leaks is of major importance, especially as you have the position of 1 million cars. You don't want that leaked. So the good part is that being a good corporation, they had a lot of policies in place on security and how to work with that, but we had to change a lot, at least on the streaming part, to make it shorter and faster and more reliable. And on the batch thing, on the batch processing, maybe Nelu can tell you there more, but there we went on a standardizing approach, where instead of delivering exactly what the customer offers, we offered a little bit less flexibility so that we can deliver to more customers. And maybe Nelu, you can talk a little bit about the standards, how you set them up, and
in this case, for the batch deliveries, for the streaming we have some products which are actually some data sets. And each data set offers a set of columns which together represents a data point in the end. Not all the customers will require all the columns, let's say.
Okay.
And we made it flexible in such way that for some customers we can deliver multiple columns, for other less, depending on what's the requirement and what was the agreement between the parties. This was one thing, and then we made it flexible that we can deliver the data directly to their own storage. If it's in cloud, if it's on a local server, that depends on their infrastructure. And this was kind of the main thing in here.
Yeah. Another thing that was interesting is that while for batch delivery we could set some standards from our side and say, okay, this is what we can deliver, on the streaming side we couldn't. They couldn't sell it because the customers already had their APIs, and basically they were saying, no, these are our APIs, you need to push the data as we require it. So it was an interesting learning process where in one case for streaming, we had to deliver a specific customer request where we had to do our own implementation, while for the batch delivery, we could just through configuration deliver the data. And by the way, this is the initial dream of this was that in the end it's kind of one solution and maybe one source code to be used for both batch and streaming. That was the ideal case. Mm-hmm. And this is what they were hoping for, and this is why they chose Spark as technology. And they were saying, okay, maybe we can choose Spark and solve both streaming and batch use cases. In the end, it looked like in practice it didn't work. The technology is not there yet to serve both the use cases good. Spark is very good for batch because you have expressive language, you can use SQL over data and do all kinds of manipulation, but for streaming it was too slow.
Okay, but talking about generally IoT projects, and you were mentioning about limitations in terms of APIs and connection and so on, and also you said before about security. So a lot of manufacturing companies are not allowed or are limited to adopt IoT because of this. How do you feel about it? I mean, is this kind of a barricade in order to adopt IoT in real processes, real scenarios, or can you maybe adopt certain things or certain processes and limit yourself there? Because I felt in the market that people are a bit scared of it, also like maybe in manufacturing processes, even accessing cloud and so on. But certain things I think that still can be automated, right? So what were your experiences?
So if I may, I'm a talkative guy. The competition, one of the big competition for our client failed because of security reasons.
Okay.
There was a TV show based on how they could get the data and follow some rich man around because they lived in some place more isolated, and while they anonymized the data, they didn't anonymize it good enough so that a researcher couldn't trace them. And because they showed that you could trace people and what they're doing and you could easily buy the data, because of that they failed. Okay. Right? So security is pretty important. Like you have a big company listed on the stock exchange, die.
Okay.
Right? So, and you have the other alternative. You had startups who were just features, no security, right? And in the end, maybe they're caught, maybe they're not. And we were also on the big side. And the good part was that for every data set, Nelu and sometimes Maria or somebody from the had to talk with their lawyers and to the security accountant just to see if the data that we are sending is secured enough. Mm-hmm. Because when you are data trading, there is a fine balance when you decide, okay, it's secure enough that we can send it, because in the end it must be valuable to the one that you're selling it to, but anonymized enough so that they couldn't, even if they want to trace back the person, and they enforced it also through contracts, what the company that failed didn't do. So there are quite a few steps that if you fail to do them properly in this automotive industry where you're data trading, then failure is a big option on security.
Okay, so you need to have like take care that everything's like legally okay and all right, and also with their departments and so on, so exactly. Who couldn't have access to which kind of data, so to say. So I guess then, or I assume that this type of discussions where customers are a bit afraid of adopting IoT or going to the cloud and so on, start all the time with this impact, okay, that is impacting basically also this kind of processes and also the data that has to get accessed from different parties. How can you maybe motivate the customer or maybe push him a bit in order to adopt these technologies? in order to get the first steps done? Are there some kind of workshops that you are doing with them, or how? What does the process look like?
From our side, it would be quite the reverse, where it wasn't us who were teaching them. It was more their lawyer side or their because
exactly.
As I was saying, they're a big company, right? They're huge, listed again on the stock exchange, so they had a big legal team that helped them do this, right? And it's good to have a legal team, especially when you're going into the data trading, which is different than IoT, because IoT is just collecting the data, and then there are multiple options. One, you can deliver some features to the customers who are sending you the data, which of course you need to make it secure, and that's something that we can help you with, and we can discuss about cloud versus on-prem and what's more secure. And data trading is a step forward where you're saying, okay, now we are trying to sell the data. Now let's see what type of agreement do we need to reach with the customers who is sending the data, and what type of agreement and contract we need to the third party who are selling the data. And in this part, on the data trading part, it's good to have lawyers if you're doing that, right? You need strong contracts in place. Now, if you're talking about security, that's a totally different solution where lawyers wouldn't help you. It's IT guys who need to help you, and who need to set up boundaries on who can do what and what needs to happen. And there you need a policy in place to make sure that everything is fine. But from my experience, if you go to a third party that just wants to get the project, they will deliver the feature, and you as the customer, you wouldn't ask about security. And most of the time, from what I see, if we're not going to the customer and saying, okay, we need to do it, but we need to do it securely, they need convincing work. They need to be convinced that the solution must be secured. Generally, for them, it's an afterthought. They need the feature, and it's your responsibility to do it secure. But you need to work together with them.
Okay, my next question would be about documentation, communication of the technical aspects, and so on. Maria, maybe this is a topic where you were involved. What can you tell about that? I mean, also that the solution that we are delivering has a certain vision, so to say, and is kind of future-proof. So you need all to consider all these documentation aspects, whether we will take care from in the future or from now on of the solution, or it's another party that needs access to that, connecting different solutions to that. How do you see that part?
So basically what happened was that, as Mihai said, it was a huge company, and we were using Confluence most of the time, and we've had each team had a different space, and you could easily see how, let's say, a data set went through all of these places, all of this, let's say, data science team, what the data science team did on the EDA part for exploratory data analysis, what were the steps for the cleaning part of the data set. And then you could see also this privacy assessment that Mihai mentioned for the security and the legal teams to review and approve in the end if they were good enough. After that, you could see how the data engineers worked with the data set. You could see the documentation of each step that was involved in there, the architecture of the solution that we have, and I guess this is
okay.
After that, the data came to, let's say, to the best solution, best architecture that we had, and then from that point we could just simply deliver it to the customer. So it was kind of a process made by multiple processes, which were kind of in a serial connection.
Okay. One thing in here to add, in most of the places, for batch at least, we use also notebooks, which are a place where you can put documentation alongside with the code and have it nicely formatted. And that also helps a lot when you want a more detailed documentation, right? And it's helpful to have it as close as possible to the source code, as when you're modifying the source code, you know for sure that you're modifying documentation. And we use that solution as well. So we had the ticketing system and everything in Confluence and the high-level architectures. But we use also the Databricks notebooks, which are, have their benefits and their downsides. Maybe we can talk about them later. And their documentation feature is actually great from my point of view, where you can just have HTML and Markdown directly along the code. And it's a lot easier to write, to read.
So if someone is familiar with Jupyter Notebook, basically they integrated Jupyter Notebook into Databricks. And the same features are available there. You can do whatever you want with them. But one of the downsides here would be that for let's say a more complex solution, like in the batch case, where we had to connect a lot of notebooks between them with the dependencies and so on, it was a bit hard to develop everything in this type of interface like notebook. It would have been easier if we would have just have the ID somewhere locally on our computer and develop from there. But the main feature that Databricks offer is the computing power, which is directly available. There you can just configure it. It's a bit hard to actually do it or connect it from your local machine from an IDE to their compute power, but you can do it, but it's not that smooth as it should be in case you're using Databricks notebooks.
I would say that it's quite bad, and I think all of you disliked it.
That's why, because we did not use it in the end, because that was the main conclusion. So
And the fact that you have to develop in browser, it's also selling to the developer a lot of the times, because you need good developers on the project, right? And everybody wants to work on something nice. And it was hard sometimes, when you get somebody with experience to tell me, hey, you're going to develop in browser. It's a shock when all your life you had your IDE of choice. IDE comes from integrated development environment, where you have a lot of features, and suddenly you start typing in the browser and working there. It has, working in a notebook has benefits, but as Nelu said, when you're getting on complex stuff, it's nice to work on your local environment, on your local machine.
I mean, you had basically a whole team who worked on this project. Who was involved from the customer side, so to say, as roles? Do you need help from developers, designers, or could you manage all this kind of developing all this kind of functionalities and taking care of all technical aspects by yourself?
So go on.
We were kind of let's say 3 teams. One of our colleagues was in the data science team. Then Maria was part of data engineering team, and then me and Mihai and another colleague were part of the data delivery team, basically.
We had also somebody in the data science team.
I mentioned.
Okay.
And in the end, when the data was prepared, we, the delivery team, had to deliver in the streaming fashion and the batch fashion. So basically that was what we had to do in here.
But just to add a little bit more context, we started as a pure augmented team, where we had one team, and we started, I think, with Nelu. I'm not sure, maybe you as well.
The 3 of us.
The 3 of us started initially. We grew to more people, but we started initially just working with them in their team to understand what they're doing. And once everything was clear, we started growing, and we started splitting into multiple teams so that each team can focus on its part. But we started slowly, as we generally prefer, with a small team of more senior or good people, just to catch up everything, and then we can scale up on our own and not let the client worry about how are we growing or what are we bringing to the project, because then we can do the onboarding.
But what we did was that we learned from them the environment, and then we managed to create our own solutions, and then start developing ourselves.
Okay, so communication and this type of cooperation close to the customers, as I first understood it, is like very important, especially in the beginning where you are like building up all this structure, so to say. I was thinking, how do you envision basically the future of IoT? Like, not talking only on the specific project that you were working on. Like, speaking generally, we were talking about data trading, which was the current case. But yeah, there can be a lot in transportation, in retail, in wherever situational process where you can adopt IoT. What I felt, for example, until now from the market and events, and what I was seeing until now is like in the last 1-2 years, maybe like more and more adoption of IoT. So it's not anymore a buzzword that is used. How do you think that it will be from now on, so to say, a bigger impact as customers see that, okay, we adopted it kind of works, it's okay, we have a future vision for it, which we can still enhance and so on the project side. How do you feel about that?
From my perspective, I would say, first of all, data is gold. So if you're in the business to sell data, there are a lot of marketplaces where you can just sell the data. And if you're collecting from, let's say you're a big company, you're collecting data from there, and just for the purpose of selling it, you're gonna make a lot of money.
Okay.
You need some processes in place just to be able to deliver the data. But if you're also searching to get some feedback about the data that you are, let's say, providing, or some other parties are collecting from you, in that case, you can improve yourself as a company.
Okay.
Which is, again, a good step in your development or in your future as a company.
Okay, maybe I can add from other projects, as I cannot count how many IoT projects we have, but let's start with a few use cases that are growing more and more interesting. First, we had the balance responsible party, who is basically an energy trader on Netherlands, Belgium, and multiple countries. And they were basically partnering with companies who are working with wind farms, and they were having devices, a lot of sensors on the wind farms, and using those IoT devices, they were trying to predict the wind speed in the upcoming period so that they can do better energy trading.
Okay.
Right? So we're seeing that machine learning is helping a lot the IoT, because the IoT sensors are pushing a lot of data, and now we're having the machine learning part who can learn from that data. And what we were helping this customer, the first interesting use case was to demand the prediction. You know, you have the prediction of weather, you have the prediction of wind, of certain elements. Now predict me what will be the demand of energy for a certain region, right? And this combination of IoT of devices who are sending you data, who are helping you do better prediction on certain parts, are then helping you to deliver, and not even saying better solution, helping you in the data, in the energy trading part, win a lot more money.
Yeah.
We are having also the other customer who is having a lot of electric buses in Germany, who is doing energy trading and who is using the buses as batteries, and they're selling the energy from the buses when it's more expensive and buying when it's cheaper. And it's using, again, this solution to win money. We're having the chemist. I'm not sure, maybe it would be nice to have an interview with the guys who are working with the chemist, who are testing the purity of the liquid, where you are having sensors to analyze the liquid, and you're getting the shape of the molecule. Then again, using machine learning, we were predicting, okay, this is the molecule that you have in the water or in the liquid. Yeah, run another test. This is the base, this is the variation, and so on. And we're seeing a lot of interesting IoT solutions, because starting from a few years back, the hardware got cheaper, got better, and now you have better cleaning solutions. You have machine learning to help with the cleaning, to help with prediction, to help with all those stuff. And we are seeing more and more hardware that is embedding software to do smarter things. If you're just having hardware and software separately, you will be less than the guy who is bringing them all together.
Mm-hmm.
And now we're seeing fridges with software, so everything will be IoT soon enough.
Yeah, absolutely. I'm convinced about that. You said, I mean, you're data specialists, both Maria and Nelu. You say data is key, and customers might sometimes have like all kinds of imagination to how to improve, to use maybe some AI and machine learning in the background. However, they do not have structured data, so to say, and there is, I guess, there is some kind of road, a path until you get to that point where you can adopt machine learning, for example. But for that, you need like structured data. What is your answer? How do you deal with such situations, basically?
Even if you have unstructured data, you still can do machine learning, because there is an area in machine learning which is called unsupervised learning, which lets you do a lot of things with unlabeled data, let's say. And you can even use some machine learning to learn from the data and just cluster that data. And basically, based on those clustered data, you can then say this cluster is the label for this data. And then on top of that, if you want, depending on the needs and how the data, what the data provides, you can then use supervised learning. But that depends on the project and on the data that you're playing with.
But
so it is not basically a showstopper, so to say, if the customer comes and says, I might not be prepared because I don't know what I do to maybe to archive, what I can reuse from that data, and there's a complete mess what is in there. So there is like no we can still help. So you can still help and the situation and say like this would be the.
Yes, but usually before going forward with any machine learning models, we have to do the exploratory data analysis in order to find some patterns. If we are going to find some patterns, then the machine learning model will find patterns. And also we'll find them and we'll maybe improve them a little bit. But if there are no patterns in the data that, let's say, you provide, we simply cannot do anything with it.
Let me maybe correct one thing in here. It's not necessarily if you have IoT that you have unstructured data. For example, in this case, we were having like 10 or so devices with different software versions, but the data was sent in a clear structure. You had multiple structure, and yes, you had to bring them to one structure, to one piece, and so on. But in the end, you have structure in the data. What's generally, and that's the general thing with the sensor, right? You're programming it to send certain data. The big problem with the data from IoT is cleaning it, right? Like, is the data correct? Maybe you bought a cheap sensor who is having a lot of errors, who is having a lot of problems. How do you detect that? How do you do predictive maintenance? You saw that some devices broke, but you have only 1% example or even less than that. And how do you predict that? So you have a lot of machine learning problems, but it's not always the case. I will say that generally it's not the case that you have unstructured data with IoT. You have generally a lot more unstructured data when you have companies who are trying to pull data from a lot of sources, especially crawlers and stuff like that. And then you're getting a lot into that problem. And related to your second point, how we can help them, there are actually two steps. One, we generally prefer that the client comes to us when they're trying to design the solution so that they can save the right data and work on the quality of the data. The main point on machine learning is a simple phrase: garbage in, garbage out. And most of the clients don't look that much into the data to see how good is the quality. And we see systems running for 5 to 10 years only to say, okay, we have a lot of quality data, and then they come to us or to the data engineers, and you can see their faces looking in the data and say, So it's useful to have data engineers work on the quality of the data from time to time, and then you can do quality machine learning on it. And it's better if you come to us early. If you come to us in the later stage, maybe we can help you build quality. Maybe we can help you to starting from now to build a quality data set, because sometimes people want machine learning and there are a few scenarios. One, they don't have the data for it to predict, right? They just don't have it. Case in which we say, okay, start saving that data, which we think are the predictors. And then we can see if we can do something with the data. Second step is, okay, let's work on doing an EDA, as the data engineers are calling it. And then we can tell you if you have something that can be used for prediction. 3, and we never had this case. You had clean data and you just needed machine learning.
Okay. So this is a dream case, so to say, that you could have, but basically never had, because I mean, also I guess also on enterprise level it's very hard to keep up also with this type of things, and to give it like to your provider and say like, I only need like machine learning on that, and let's implement it. Okay, so we were talking about innovation, about automating things, about cloud, about security, about the things basically that customers usually are afraid of, and to go into the cloud, or adopting IoT, using machine learning. So maybe a final words, what you like to maybe to push a bit the customers, to say like give them a bit more power and confidence, so to say, to at least talk about these things, and to see how we can support them.
Okay. Let me start with the first one, security, right? So, for example, with the electric buses company, right? The competition who was also bidding them, who were going for a cheaper model, if I remember correctly, they suggested an on-premise system. And basically we went for the cloud system. Yeah. And our arguments were pretty simple. One, on the on-premise system, you have like an outside box, and if somebody penetrates it, generally you have no other security. While in cloud, you can have security in depth. The second advantage of cloud is that generally for startups and for a lot of companies, you don't know the exact demand. And instead of buying or renting a few hardware and spend a lot of time on working with the hardware, just deliver the solution. And sometimes it's amazing that you can do it with almost for free, because you can use a lot of serverless services and so on. So most of the time we recommend cloud to the customers, because we can do security in depth. We are experts. We are certified in Azure and AWS as a company in general, and it's a lot faster to do. And once people realize that spending a lot of money on development just so that you have an on-premise system that it's harder to update, you need to manage everything. What happens if you don't have electricity, internet, blah, blah, blah. Instead of saying, okay, I want to go to cloud where everything needs to be in multiple data centers, so that if one data center goes down, I have another one, each with their own separate electricity, internet, and everything, right? This is the power of the cloud. You don't have to do anything for it. Plus, you have the features. I can develop the features per day a lot faster than you.
Okay.
So this is the first thing related to security and going to the cloud. A lot of people are worried that cloud is less secure, but I would argue strongly against it, that cloud is a lot more secure than what people are doing on premise, and they're saying it's secure.
Okay.
I'll let also.
What are your thoughts, Maria? What could basically improve this kind of situation, that more and more companies adopt IoT? What would be your final words, so to say, to this, or add basically to this topic?
I think that the limit is only our imagination, right? Because technology is developing every day, and I think that almost everything is possible or will be possible in time. So just have an idea or start with an idea and grow from that. Start developing from that.
Perfect. How do you see it, Nelu?
I would say that in this field, you have to move with the data. You cannot stay on the same spot where it's comfy, let's say, sometimes. You just have to move because the data will change. And what you need to find is to find whenever the data changes and to adapt accordingly.
Yeah.
Because that way you will stay on top of the market with a lot of, let's say, good practices that you can have, good feedback from your possible clients, and also a lot of innovation that you can offer. And data will help you in that sense all the time.
Perfect. Yeah, so I think this was it for today. Thank you very much. We have our two data engineers, Maria and Nelu, architect, Mihai. Thank you very much for the session. If you have any questions, just drop a comment and we will definitely get back to you with an answer, or you can approach any of my colleagues with any kind of topics related to IoT, machine learning in the logistics, but not only. So feel free to do that. Thank you very much.
Thank you.